Hello and welcome. Today we're going to continue our discussion on factoring polynomials completely. Previously, we've discussed factoring polynomials with two different variables. We've talked about factoring polynomials whose exponents are greater than 2. We've also talked about factoring the three different types of polynomials: binomials, trinomials, and polynomials with 4 terms. To begin, we're going to go ahead and recap those three different types of factoring. First, we'll talk about factoring a polynomial with 4 terms. In order to factor a polynomial with 4 terms, we factor by grouping. Our first step always, no matter what type of factoring we are doing, is to take out the greatest common factor of all terms. So looking here at this polynomial, it has 4 terms, and I see a 3 in common between all 4 of those terms. So I factor out that 3, leaving me with 3n to the third minus 9n squared minus 1n plus 3. That 3 that we factored out is just going to remain on the front. We are going to ignore it for the time being. Now inside these parentheses, I see 4 terms, which I can factor by grouping. I split them down the middle, take out the greatest common factor from the left, that is the 3n squared, and I'm left with n minus 3. On the right, I take out a negative 1, and I'm left with n minus 3. Remember, we always want our first term to be positive, and since my first term on the right is negative, I factored out that negative with my 1. Now I see n minus 3 repeated, so I factor out that n minus 3, leaving me with 3n squared minus 1. And again, that 3 from our original step should just stay on the front of our final polynomial. Now look at each of your factors before you move on. Make sure that they are both prime. N minus 3 is prime because there is no greatest common factor between the two, and it is not the difference of squares, so we cannot factor it further. 3n squared minus 1 is also prime for the same reasons. There is no greatest common factor between the two, and it is not the difference of squares, so we cannot factor it further. Therefore, since all of our factors are prime, this is our final factored form of this polynomial. With 3 terms, we proceed with a very similar method. Step 1, as always, take out the greatest common factor of all the terms, if there is one. Between those 3 terms, I see a greatest common factor of 2, so I'm going to factor this out. 2 leaves me with 5v squared minus 12v plus 4. And now we factor that remaining trinomial. To factor this trinomial, I have 3 terms, I need 4. Once I rewrite this with 4 terms instead of just 3, I can proceed by factoring by grouping, as we did on the left. So my first step is to rewrite this as 4 terms, using my diamond method. Multiply the first coefficient with the last term. 5 times 4 is 20. That goes on the top of your x, and on the bottom, I have my coefficient of the middle term, which is negative 12. I need 2 numbers that multiply to 20 and add to negative 12. Those 2 numbers are negative 10 and negative 2. So I rewrite my negative 12 in the middle as negative 10v minus 2v. It is the same thing as negative 12b, we just made it look a little bit different. We still have the plus 4 on the end and that 5v squared in the front. From here, I split my polynomial down the middle, take out the greatest common factor of 5v from the left, leaving me with v minus 2. And on the right, again, I have a negative coefficient for my first term, so I'm going to factor out a negative with the greatest common factor of 2, leaving me with v minus 2. I now see v minus 2 repeated, so I factor that out as a greatest common factor, and I'm left with 5v minus 2 in the second parentheses. Do not forget to bring down the 2 on the front, and then double check to make sure that each of your factors are prime. v minus 2 is prime since there is no greatest common factor and it is not the difference of squares. 5v minus 2 is also prime for the same reasons. Therefore, this is the final factored form of our original polynomial. Our third method is factoring a polynomial with 2 terms. Step 1, as always, look for a greatest common factor. Between 32 and 5, I may take out a 2, leaving me with 16x squared minus 25. Since the first term, 16x squared, is a perfect square, and the last term, 25, is also a perfect square, and they are being subtracted, this is a case of the difference of squares. So what I'm going to do is focus on the inside of this set of parentheses and rewrite it as two perfect squares being subtracted. To rewrite my 16x squared, 16 is going to become a 4 squared, and x squared I can leave as x squared. Now I have one term all to the second power, and my 25 I'll rewrite as 5 to the second power. So my bases are 4x and 5. To factor the difference of squares, I take these bases, 4x and 5, I add them, and I subtract them. Again, do not forget that 2 from the beginning needs to come down on the front. Look at both your factors to make sure that they are prime. 4x plus 5 is prime because there is no greatest common factor, nor is it the difference of squares. And 4x minus 5 is also prime for the same reasons. Therefore, this is our final factored form of the original polynomial. For the rest of today's lesson, we're going to focus on factoring trinomials. The difference with these trinomials from ones that we've talked about previously is that they are not in the correct order. Anytime you are factoring, your exponents must go from highest to lowest. So if you notice, for example, in this first polynomial, I have an r squared, and then no r's, and then an r to the first power. What I need to do is rearrange these so I have the most r's in the first term, that's my r squared. And then after that I have r to the first, which would be this negative 3r. And then after that I have the term with no variables at all, which would be my negative 4. Now that I've rearranged this so that my exponents go from highest to lowest, I may factor it as we just discussed on the previous slide. Multiply your first coefficient, in this case it's a 1, by the last term, negative 4. 1 times negative 4 is negative 4, and in the middle I'm adding to a negative 3. Two numbers that multiply to negative 4 and add to negative 3 would be negative 4 and positive 1. So I rewrite my negative 3 as negative 4r plus 1r. I still have r squared in the front and minus 4 in the back. Split this down the middle and take out the common factor of r, leaving us with r minus 4. And on the right, the only thing I can take out is a positive 1, leaving me with r minus 4. I see an r minus 4 repeated, so I factor that out, leaving me with r plus 1. To the right, again, I need to rearrange my polynomial so that the exponents go from highest to lowest. I'll start with my 4n squared, that's the highest exponent that I see. After that, I'm going to go ahead and cross this out so that I know I used it. After that, I see n to the first power, so that term is going to come next. So I have positive 26n, and the last thing that you have in your polynomial is a positive 40. So now my variables go from n squared to n to no n's in the last term. From here, I proceed to factor. I take out my greatest common factor if possible. Here I see a common factor of 2. When I factor that out, I'm left with 2n squared plus 13n plus 20. And I use my diamond to rewrite this trinomial as 4 terms. Multiplying the first term and the last term, 2 times 20 is 40. And on the bottom, I have the coefficient of the middle term, which is 13. Two numbers that multiply to 40 and add to 13 are positive 8 and positive 5. So I rewrite my 13n in the middle as positive 8n plus 5n. I still have 2n squared in the front and plus 20 in the back. I split this down the middle and factor out 2n from the left, leaving me with n plus 4. And on the right, I factor out a positive 5, leaving me with n plus 4. I see n plus 4 repeated. When I factor out that n plus 4, I'm left with 2n plus 5 in my second parentheses. Do not forget, We factored out a 2 in our second step. That 2 needs to remain on the front of your polynomial. Make sure you double check each of the factors to make sure that they are prime. In this case, n plus 4 is prime, and 2n plus 5 is prime. Therefore, this is the final factored form of our polynomial. Go ahead and take a moment to pause the video and try the next two on your own. For the first, you should have ended up with x minus 2 times x minus 2. However, since those are both the same, we can simplify by writing it as x minus 2 all squared. So this should have been your final answer. And second, you should have factored out a greatest common factor of 3, and you have two other factors of m plus 3 and m minus 2. The second and last concept I want to cover is factoring when your leading coefficient is negative. Remember, your leading coefficient must always be positive. So step 1, anytime we're factoring, we look for the greatest common factor of all three terms. In this case, even if there was nothing else in common, since that leading coefficient is negative, we would have to factor out a negative 1. But here there is more than just a negative 1 I can factor. I can factor out a 2 from all three of those terms. When I take out the negative, my negative 4 becomes a positive 2a squared. My positive 6 becomes a negative 3a, and my positive 40 becomes a negative 20. I now use the diamond on the remaining trinomial inside the parentheses. 2 times negative 20 is negative 40. My middle coefficient is negative 3. Two numbers that multiply to negative 40 and add to negative 3 are negative 8 and positive 5. So I rewrite my negative 3a as negative 8a plus 5a. I still have that 2a squared on the front and the minus 20 on the back. Splitting this down the middle and taking out the greatest common factor of the left, I take out a 2a, leaving me with a minus 4. And on the right, I take out a positive 5, leaving me with a minus 4. I see a minus 4 repeated. Factoring that out leaves me with 2a plus 5. Don't forget you factored out a negative 2 at the beginning. This negative 2 stays on the front. Since all of our factors are prime, this is the final factored form of our original polynomial. To the right, again, since my leading coefficient is negative, I have to take out a greatest common factor that is negative. And between 6, 8, and 2, there is a common factor of 2. So I'm going to factor out a negative 2 from this polynomial, leaving me with positive 3n squared minus 4n plus 1. Using my diamond on this trinomial inside parentheses, 3 times 1 is 3, and I'm adding to a negative 4. Two numbers that multiply to positive 3 and add to negative 4 are negative 3 and negative 1. So I rewrite my negative 4n as negative 3n minus 1n. I still have 3n squared on front and a plus 1 in the back. So I split this down the middle and take out my greatest common factor of 3n, leaving me with n minus 1. And on the right, I take out a negative to make that first coefficient positive, and the only thing in common between the two is a 1, leaving me with n minus 1. Factoring out that n minus 1, I'm left with 3n minus 1 in my second parentheses. And don't forget that negative 2 that you factored out in the beginning. Since all of your factors are prime, this is the correct final factored form of your original polynomial. Go ahead and take a moment to pause the video and try the next two on your own. From the first, you should have factored out a negative 2, and the remaining factors should be 5b minus 4 and b plus 3. On the right, you should have factored out a greatest common factor of negative 3, and have two remaining factors of 3n minus 5 and n plus 4. We're going to go ahead and quickly put these concepts together. Step 1, let's make sure our variables are in the correct order. My negative 9v squared should come first, then my negative 21v, and my negative 12. Now that I've rearranged this, I'll take out my greatest common factor of negative 3, leaving me with 3v squared plus 7v plus 4, and I'll factor that remaining trinomial. Go ahead and finish this one and the next 3 on your own, and we'll pick up here in our next lesson. Enjoy the rest of your day.